Hello and welcome to Astronomy 3B. This is going to be a worksheet I'm going to give you to work with 3B, and you're going to actually be coloring the diagram on this side. I'd actually like you to write some text on this side as well as in here that's going to go with the notes. I'm not sure you can actually write all the things from the PowerPoint on this, but probably what I'd like you to do is to actually take notes like you normally do, but then just notice that on these diagrams, these are the layers that we're going to be talking about. Okay, so let's go to this. 3B, astronomy, layers of the atmosphere. And we're talking about basically what makes the Earth so special. This is going to be from outside the Earth, looking in. And the first thing, this is a picture of a space shuttle. I'm not sure which one, from the International Space Station. And you can actually see the sun is in the background illuminating the atmosphere, and I'm not sure if it's actually coming in or coming out. It kind of depends if this is on the downward side or the upward side of the shuttle. But you actually can see we have an atmosphere, very thin, kind of reddish at the bottom, probably a beautiful red sky if you're down here on the Earth. And most of the atmosphere, 70% of the atmosphere is way down here, and the other 25% is mostly at the bottom of this area. And when you get up here, and this is one reason why the shuttle's up here, when you get up into this area, there's very little atmospheric gases, which will slow down the shuttle, which is why we put our satellites up there. Okay, so for 3B, this is actually a picture that comes from Earth Science reference tables in an Earth Science book, and it's something that I actually gave my kids in Earth Science. But what you take a look at is you can see the altitude of the atmosphere going up to 160 kilometers, which is about 100 miles. You can see they track the atmospheric temperature, they track the atmospheric pressure, and the atmospheric water vapor. And one of the special things about our planet is that we have three phases of water, and somehow we have to get the water from the ocean to the land. And the way we do that is we evaporate the water into the atmosphere, but you can actually see that the water in the atmosphere doesn't go up very high in the layers of the atmosphere. So it pretty much tanks out at around, what would it say, 17 miles or maybe 20 kilometers up, and then there's no more atmospheric water vapor. Atmospheric pressure, you can see it actually goes down 75% until we get to this line, and the other 25% is mostly in the next layer, although the atmospheric pressure does go up and up and up and up until it eventually reaches zero. And then we have temperature, and the temperature seems to be doing the really weird stuff. It looks like it cools and it warms and it cools and it warms. And the way it actually works out, layers of the atmosphere are actually named after what they're doing with temperature. Bottom layer is a cooling layer, next layer is a warming area, next area is a cooling area, and the next area is a warming area, and eventually it just keeps getting warmer and warmer until we reach what's called the exosphere, which is out here. So the first one is the exosphere. This is the outermost layer and fades into space. And on your diagram, I'd actually like you to find number 7, and I'd like you to color it. I don't know what color gray is, but it's supposed to be gray, and it looks like I deleted the G. And this layer really belongs to space, and this is where we have our artificial satellites, many, many, many of them, and as well as the Space Shuttle and International Space Station. So here's the exosphere, located basically going up forever, and great place for satellites. Next layer is the thermosphere, the heat sphere. This is the outermost layer. It makes up about 1/1000th of the total atmosphere, and I'd like you to find number 6 and go ahead and color it red. In the exosphere and thermosphere, we have what's called the ionosphere. This is what old-time radio enthusiasts used to use. We would send up radio waves, which would essentially go out to space, but they'd hit these ionized gases, and then they would bounce back down. And from this, we could actually, talk to people around the planet. You put up a satellite, or you put up a radio station, and it's line of sight, but the Earth drops away. So this allowed folks to bounce off. And again, this goes around the Earth. It allowed them to bounce off the ionosphere and talk to people all over the planet. Next one's called the mesosphere. This is the middle sphere. This is the layer that follows and it is the coldest layer of the atmosphere. The thermosphere is the warmest one. This is the coolest one, and I'd like you to find it and color it blue. One of the special things about the mesosphere is it actually has what's called the, actually I'm not seeing it on here, but we actually do see the aurora borealis in this area. Okay, so here's the ionosphere. And the ionosphere is found within this layer. It actually extends up into the exosphere also. But this ionized gas actually allows the solar wind from the sun to produce what's called the aurora borealis, the light of the north, and the aurora australis, the light of the south. And it actually takes the free electrons that are up there and causes lots of really beautiful colors. And if you could find number 4 and color it green. Here's a GIF of auroras. They come in lots of different colors. I like this one a little better. And you can see stars in the background moving with the celestial sphere, but you see really beautiful colors in the aurora. And again, this is up in the mesosphere, the top part of the mesosphere, and even the lower exosphere or thermosphere, which actually lights up really beautifully. Next layer down, we have what's called the stratosphere. This is the layered sphere. This is the one where we actually have high-flying supersonic aircraft flying up here. The regular commercial aircraft doesn't get up this high. We have to be traveling really fast because the air is so thin. You don't get a lot of lift from the wings. So our planes, which don't fly as fast as supersonic planes, have to fly down here in the lower, more dense gases. But this is where the supersonic jets actually fly, and I'd like you to find it and color it yellow. Inside the stratosphere is what's called the ozone sphere, and the ozone comes in good and bad. The stuff that's up here in the stratosphere is the good ozone, and ozone is just a molecule of 3 oxygen atoms, and what it does is it takes high energy waves from the sun and it splits, and it absorbs the energy by splitting off one oxygen, and then the oxygen very quickly comes right back in to get the next gamma ray, and what it does is it protects us. Burning fossil fuels also produces ozone. This is the ozone that's down in the lowest layer of the atmosphere, our layer, and it's what's called bad ozone. And it can affect people with respiratory systems that aren't working at 100%. So elderly, or if you have respiratory ailments, this could actually make you weaker and harder to breathe. And if you take a look, here's the stratosphere. Mesosphere is above it. That's where we have the ionosphere and up. And this is the stratosphere with the ozone layer, which is a band of oxygen molecules that protect us from high energy gamma rays. And if you could find the ozone layer, color it orange. The lowest layer of the atmosphere is called the troposphere, and this is the one where we live. It extends up to about 7 miles, around 10 kilometers. Nearly contains all the carbon dioxide, greenhouse gas to protect us, all the water vapor for the clouds and pulling moisture from the ocean to the land, and the atmosphere is here, the whole atmosphere is here because the Earth's gravity can hold the gases. It's one of the very important things about our planet in terms of life as we know it, being able to change the water and hold the water as liquid, be able to hold the water as a solid. It's called subliming if it actually goes up into the atmosphere without melting, and then hold the water as water vapor and or ice crystals up in the top part of the cloud. So 75% of the Earth's atmospheric gases are here. It runs from sea level up to about 7 miles, and that's supposed to be a squiggly. It's the thickest at the tropics because, and I'm talking about thickest in terms of miles up because of the heat, but it's densest and thinnest at the poles, and it actually does contain Mount Everest, which is 5 miles up. So it actually extends up a little higher than Mount Everest, and all life as we know it is found in this atmosphere, at least all the life that you can name, found inside this layer of the atmosphere. And please color it purple. And again, you want to color these sort of lighter color, don't want to color them really deep. Here's some information I'd like you to complete in your notes and your diagram. So when you actually see this, I'd like you to write the information out here. In terms of how high these things are, some of the special characteristics. You've written, I hope, the words in these boxes, and you've colored the layers as you see them here. I'd also like you to color the layers here. I do want you to notice that the troposphere is ended with something called the tropopause, the stratosphere with the stratopause, the mesosphere with the mesopause, the thermosphere with a thermopause, and the exosphere goes on essentially forever. But we do get the ionosphere located in this area. So the exosphere up there, actually this is the mesosphere. This would be this is not the exosphere. That is the exosphere. I'm not sure how these work, but troposphere, make that purple. Go ahead and color these the way they are. Color this one the way it is, this one the way it is, and color these two also, although it looks like the diagram may be a little off on this side. Exosphere, outermost layer of the atmosphere, gradually fades out to space, maybe not really belonging to the Earth, maybe not really belonging to space, maybe a little bit of both. Ionosphere, atoms are charged, and these are due to intense radiation. We can use them for radio contact. Thermosphere, the hottest layer of the atmosphere. Mesosphere, the coldest layer of the atmosphere. Extreme high winds, and this is where the jet streams are located, the polar, the polar and the subtropic jets, which we talked about in class. And this is also where really fast airplanes fly. Stratosphere, very little water vapor and dust. It does contain the ozone layer, which protects us from high energy gamma rays and X-rays, protects humans from all organisms from absorbing the ultraviolet rays as well. Tropopause, this is the area that actually ends the troposphere and into the stratopause. Temperatures remain constant. Clouds in this region are all made out of ice, but they're relatively thin, like cirrus clouds. And as you move from this layer, the temperatures in this, from here on out, they change. So they get warmer up here and they get colder down here. This is the closest area to the Earth. This is the layer in which all the weather occurs. It's the layer where we're located and nearly has almost all the carbon dioxide and water vapor found here. So I'd like you to take these characteristics and actually put them into that diagram. Okay, so special Earth. What makes the Earth also special? Well, it has a diameter, and it has a diameter of about 12,000 kilometers. That should be a comma. Got all kinds of mistakes in here. 12,000, almost 13,000 kilometers, and that's from the center of the Earth out for one radii, and for the other radii, so making the two radius the diameter of about 12,000 miles. Circumference is 40,000 kilometers, or about 25,000 miles, and if it's 25,000 miles around, it takes 24 hours to go around. Right around here in the equator is this location, so this circle that goes around is actually spinning at about 1,000 miles an hour. And it gets less and less as you go to the poles, and if you get all the way up to the North Pole, someplace up in this area, you don't have any forward motion. So we're traveling at about 700 miles an hour toward the Atlantic in this direction, which would have all kinds of ramifications if the Earth were to stop, and we can talk about that later. And it has a mass of 5.9, almost 6 million kilograms. So to get pounds, you'd have to multiply this by 2.2. So 6 million, almost 13 million pounds. That's a lot of mass. More factors. Gravity is one. All other gravity, when we talk about being less than one or more than one, is based on the Earth's gravitational pull. This is what's holding our atmosphere to our planet, also holding you to the planet. Average temperature, 0 up to about 100, 136, actually I think is the record, even though this one says it's 129 to 131 degrees Fahrenheit. Pressure is called 1 atmosphere. If you're down at sea level, you have 1 atmosphere of air pressure pushing down on you. And when we talk about other atmospheres and other planets, it's all based on this 1 atmosphere. When we actually get up on top of mountains and this atmosphere decreases to like 0.75, or if we go down to Death Valley and it becomes 1.03, we're talking about the regular mass of our atmosphere, the gravitational pull, pulling it down to make about 15 pounds per square inch. Atmospheric makeup, it's mostly nitrogen, only about 20% oxygen, and it has trace amounts of argon, carbon dioxide, and water vapor. So you can see 2% of it. It has all the other gases, including carbon dioxide, which we talk about being the greenhouse gas. So it doesn't take very much carbon dioxide to have a big effect on our atmosphere and climate. And all of the water vapor, all the clouds you can see up there, all the water vapor in between the clouds, still it's only less than 2%. Length of the day, 24 hours, really 23 hours, 56 minutes, and 4+ seconds. This is our the reason we have to actually equate things differently. Length of the year, 365 days. Well, it's actually 364, 5 hours, 48 minutes. And the reason we have, and that's another mistake, the reason we have leap year every 4 years, or 4 days, yeah, 4 years. Soil, if present, it's going to be very firm. Up in the mountains, you get very little soil, but down in the valley, it's very firm and very good for crops, nutrient-rich soils. Wind speed 0 to 50 miles per hour. We're actually under a wind advisory here today, and so you probably have lots of wind. You may have branches coming down, hopefully not trees, hopefully not electric loss, but we did lose electricity last night for about a minute. Some storms may actually be higher than that, and the record is actually over 300 miles an hour. So some storms can kick it out to 231 miles per hour, and that works out to 103 meters. That's a football field plus every second. Very quick wind. Okay, features. We do have polar caps, high latitudes. We have ice in high altitudes. We have lakes with liquid water. We have trees. We have mountains. We have plants. We have volcanoes, beautiful volcanoes, humans, animals, and nature. Hazards. Well, we have volcanoes. We have tornadoes. We have storms. We have earthquakes. We have volcanic eruptions. We have hurricanes. We have tsunamis. We have typhoons. We have mudslides. We have tornadoes. We have avalanches. We have electric storms with lightning. So with our atmosphere, we do have lots of other things. And with our Earth, we have lots of other things that actually do cause problems and hamper us in lots of different ways. But we do have very special things to make this planet special. So the Earth is special, even if it's only for us living creatures. We need liquid water, and water does lots of really cool things about eroding material, which actually puts minerals in the water for life that's in the water. We need salt water, we need fresh water, we have life in the oceans which produce most of the oxygen for the living things. We do have water getting up to the dry land and producing green. We have beautiful fresh water, which most life needs. We have water for rice fields, and you can actually see all the rice fields are here, beautiful colors, but trying to actually hold the water so they flatten the land while supporting the land below it or above it, so they can actually make another flat land so they can collect the water for the newly planted rice. Most of what we think about being the Earth is in the troposphere, the weather sphere. We do have hurricanes, we have typhoons, we have regular storms, we have the polar jet up here, which is keeping the cold air up in Canada. This looks like it's a summer picture, especially with hurricanes down here in the South Atlantic moving into the Gulf of Mexico, and I'm not sure what hurricane that was. But this is the polar jet. The subtropical jet's probably way down here, which is actually keeping the really warm air down here for which we talked about for being the rainforest. And you can see deserted areas, lots of moisture in some areas, very little moisture in some other areas, lots of moisture, very little moisture, and then more moisture down there if we could actually see it. And that extent dries all the way over here to Africa, but the lower part of Africa is in this greener area. So it's all produced by the water vapor that's in there. We should, because the Earth doesn't care if we reuse, we reduce, or recycle, but man does, and life does. You should always try to reduce, then you should try to reuse, And then if you can't do any of that, then you should try to recycle. But do first, second, third, and this is where we stop. Okay, that is 3B for astronomy. Why is the Earth special? Adios.